So today we're going to learn about how to balance a tree, right? Well, not to basically balance a tree, basically verify if the tree is balanced or not. Uh, yeah, in order for us to do that, we need to find the minimum height and maximum height. So the minimum height is their operation is very similar, but they're doing the opposite way of each other. So uh, that's why we have to code for each functions. And yeah, and we have to code for isBalance, right? So to verify that if the tree is balanced or not. And the concept is basically simple. The tree is balanced if we have same level of leaves, right? So they are on the same level, then the tree is balanced. And they have only one edge or difference of only one edge, then the tree is balanced. So in this case, the difference is only one edge right here too. So this tree is balanced as well. And this one doesn't have any edge, so the node itself is already balanced. In this case, we have the edge of more than one edge, so not balanced. Also for this one, it's not balanced, and also for the other ones because they have more than one edge, and they are not in the same level. So basically, that's what how to verify a binary tree is balanced or not. Okay, so the reason why are we trying to check if a tree is balanced or not? Well, a balanced tree is always the best way to manipulate and also sort the data, and it's easier to handle basically. So that's why we are doing this verifying things for this code. So let's code first with the minimum height. So this dot find min height. And also as I didn't explain earlier, height of a tree is between a root and a leaf. So basically from the root and a leaf right here, and between right here. So that's the height. So 1, 2, 1. Okay. So let's go with the function, and we're gonna pass. No. So in this case, we are using root as a default argument, and we're passing it to node, and we're going to check if a node is empty or not. If it's empty, then we're going to return -1, indicating that a tree is empty and we have nothing to balance there. So however, if a left child is no and node.right is no, then we're going to return 0, indicating that there's only one node, so it's already balanced. And then right here we're going to check if node.left is no, then we're going to check we're going to return 1 plus this dot find min height, and then node.right branch, indicating that hey, we have to check the right branch. If the left is not there, then we have to check the right. So if node.right equal to no, then we're going to return, oh sorry, this one's supposed to be plus 1 plus this dot find min height node.right. And so that's what it looked like for checking the branches, so traversing the branches. So yeah, so if there's nothing on the left, then we will check the right. If nothing on the right, we will check the left. So basically navigating through the nodes. So 1 at the end of the return, if we're going to have to find the min of each from the branch, the left and right branch. So this dot find min height, and then we're going to pass no dot left here, and then this dot findMaxHeight, and then we're going to pass no dot right. So that's it for finding minimum height. And yeah, so if we look at this trees, right, what we're doing right here is that recursive function is something like going one door to another doors, right? And we traverse and check if the condition is true, and we are navigating through these nodes, and then when we return, we are adding numbers based on these conditions that's true. So the last leaf, right, that will be this conditions right here. We have only one node, so we're just basically returning 0, and that in this case we're returning 0, and then once that 0 comes, we have to check if it's only left or right. So in this case only right, so that right have to go to right here. So we have to go in again into another left child, and in this case the left is null, so we have to go to the right child, and so we start counting again from that point. Otherwise it's going first this first, and then we couldn't count because it's just basically returning 0. And now on the second time we're going to the right and we're counting from 1 again, right? So that's what a recursive function is basically. It's just like going door to another door, and then when we returning back from that doors, we just adding numbers based on the conditions, right? Okay, so in this case we add all the hatch and we verify, basically not verify, basically count the minimum height from the branch. So similar to this, we will calculate for the maximum. Pretty similar to, very similar to the minimum height. So where's the, just copy and paste it. Okay, right here. So this will be maximum height, and the top will be minimum height. Okay, so let's just change this into max. All right, and now we're going to change for each functions call right here, because it's max now, and change this into max. The operations are very similar, but it's just the functions, the functionality that change. Okay, so max, nice, and we just returning that. Okay, control and enter. Let's see. Yeah, it worked right here. See, max and height, minimum height, so it worked. Okay, so we just have to implement the balance functions. Okay, so this will be verifying balance tree. Okay, so similar to the functions, yes, balance, we're going to call it, name the functions, and then pass the tree, this dot root, and is that correct, this dot root? I'm sorry, my eye says all over the place. Okay, this dot root. Okay, so and right here var value, and then we will try to calculate the difference of min and max. So find min height, and then pass the node, and yeah, basically copy this, and then find max height. So we will return value if it's equal to 0 or value if it's equal to 1. So verifying balance tree if the difference is 0 or 1. In that case, the tree is balanced. So one of them, if one or the other true, then the tree is balanced. Okay, so it will return true. Control and enter, and there we have it. It worked. So that's how we verify a tree is balanced or not. All right.